So first we will do introduction in linear regression. Linear regression is one of the simplest and most widely used algorithm in machine learning. It's a supervised learning algorithm used for predicting continuous outcome for independent variables based on their other independent variables. In other words, linear regression helps us understand the relationship between variables and can be used for predictions. So, what is linear regression? As its core, linear regression attempts to model the relationship between variables using a straight line. The line is the best fit that minimizes the error between the predicted values and actual data points. For single variable, the model looks like this. So our real-time example and our formula is y equals to beta 0 plus beta 1 into x. So where y is the predicted output dependent variable or x is the input feature independent variable. Beta 0 is y input which is value of y when x equals to 0. B1 is the slope of the line which indicates the effect of changes in x or y. And, and now we will discuss about the simple versus multiple linear regression. So simple linear regression involves a single independent variable called x. Multiple linear regression involves two or more independent variables, making the equation more complex. In this case, the model learns the relationship between multiple features x1, x2, and xn, and the target variable is y. Objective of linear regression is the goal of linear regression is to find the fitting line or hyperplane. This is done by the estimated value of beta 0 plus beta 1 or beta 2, beta 3, etc. in the case of multiple variables. That minimizes the difference between the predicted values and actual data. This is often done using a method called ordinary least square OLS, which minimizes the sum of square residuals. Training the models. Training the linear regression models. Yes. So training the linear regression models involves adjusting the parameters beta 0, beta 1, and beta 2, etc. such that predicted output is the closest as possible to the true output. This is done by minimizing the cost function, usually the mean squared error, which is average of the square of the differences between actual and predicted values. Mathematically, the cost function can be written as j beta equals to bracket 1 by 2m bracket into sigma y minus y bar whole square. So where the number of training example is y is the actual output and y is the predicted output. Fifth, making predictions. Making predictions in linear regression in machine learning is also known as once the model is trained. It can predict new data points. For example, if we train linear regression model to predict house price based on square footage, we can use the model to predict the price of new house given its square footage. That's a brief overview of a linear regression. Let me know if you'd like a deeper dive into parts and thank you for this video.